Okay, students, today I'll discuss one very relevant article in physics, that is radius of curvature is there. So let us discuss radius of curvature, right? So first, let me explain you what is the difference between radius and radius of curvature. So see, we are discussing about radius when radius is constant, then we simply say radius. And now radius of curvature. So in so many problems we are calculating the radius of curvature when the radius is not constant. So when the radius is not constant, then we talk about radius of curvature. Right? So when radius is constant, then you are talking about simple radius, and when radius is not constant, then you are talking about radius of curvature. For example, parabola is there, ellipse. So in this case, radius is not constant. So at different points, it is made up of certain curve which has certain radius. So then in this case, we talk about radius of curvature or projectile motion. That is, in any point you are just throwing a ball, and then you are talking about this parabolic curve. What is the radius of curvature is there? So when you want to calculate the radius of curvature, this is defined is equal to an. This is the component of acceleration normal to velocity. Let me repeat here. That is, you are not taking the component of velocity, but you have to take component of acceleration, which is normal to net velocity is there, right? So that will be normal to net velocity. This is the net velocity. So you are not taking, so this is the net velocity. You are not taking component of velocity, but you are taking the component of acceleration is there. Then this is the ratio of these two gives you radius of curvature at that point is there. For example, suppose you are throwing a ball and this is u velocity. So suppose one point is O and one point is A. So find the radius of curvature at first, at the highest point, and second at the point of projection, right? So at the highest point, suppose A is the highest point is there. A is the highest point. This is the highest point is there. This is the highest point. So at this point, G is acting downward, and at this point, all of you might be knowing u cos theta component remains constant, and at this point it is what? U sin theta. So first radius is u cos theta square upon G. So I do not to take any component of G, because this is already fulfills our condition. They are always, G is already perpendicular to its velocity is there. So at this point, so this is us square cos square theta by G is there. Now at the point of projection, so at the point of projection, if you draw, then at this point, at the point of projection, velocity is in this direction. and G is in the downward direction. So are they perpendicular? Answer is no. Now there are two options are there. I have to take component either velocity or acceleration, but already I told you have to take the component of acceleration. So let us take the component of acceleration. This angle is theta. So this is so that this will be 90 degrees there. So from geometry, this is theta, it is 90 minus theta, so it is also theta. So it is G cos theta. So in this case, R is U square upon G cos theta. So in any case, we can calculate radius of curvature. Okay, so in the next video, I'll discuss some other things. Thank you.